An arc subtends an angle of 60 degree in the center of a circle whose radius is 14 centimeter. Find the length of the arc and area of sector formed by arc. Also find area of segment formed by chord. Let's first draw a circle to see what all is given to us. We are given a circle with a center O, and we are told that there is an arc which subtends an angle of 60 degree in the center. Now, let's call this arc as PQ. Okay, so this forms an angle of 60 degree in the center of a circle whose radius is 14 centimeter. So the radius is 14. Find the length of the arc. So the first thing you need to do is to find the length of arc. So length of arc, this we know is theta upon 360 degree into 2 pi r. What's the value of the theta? What's the angle formed by the theta at the center? 60 upon 360 into 2 into pi into r. What is the r? R is 14. Six goes into 36. 6 times 6, 3. Okay. There's nothing further you can do. So what are you left with? 22 into 2 upon 3, or 44 upon 3 centimeter. Okay. Second is area of sector formed by arc of 60 degree. Again 60 upon 360 into pi r square. That's the corresponding part of the area of the circle, which is the angle vis-a-vis total angle, or 60 upon 360 into 22 upon 7 into 14 into 14. Again, this we had done over here, so 1 by 6, 11, 3, if you do it by 2, 7 goes into 14 2 times. Anything else? I guess no. So this time you have 22 into 14 divided by 3. So this is the area. This is the length of the arc. Also find area of the segment formed by the corresponding chord. So if you join PQ, then what is the area of this portion? Right? Now we know that area of this portion, area PQ is equal to area of OPQ okay, minus, let's call this as S also. So area of OPSQ minus area of triangle OPQ. This we've computed here. So 308 upon 3 centimeter square minus. We need to find out what's the area of the triangle OPQ. So let's take triangle OPQ in isolation. You have 14 centimeter, you have 14 centimeter OPQ. Now you know area of a triangle is equal to half into base into height, or half into PQ into, let's say we draw a perpendicular from O to PQ and call it as ON, right? Now a perpendicular is going to have a 90 degree over here. So in this triangle, we don't know what is PQ, we don't know what is ON. But what we know is that angle POQ is equal to 60 degree. Okay. Now can we prove that both these triangles are congruent? Let's use the RHS side for a right angle triangle. We know that angle PNO is equal to angle QNO. Both are right angles. ON is equal to ON, common, and OP is equal to OQ, radii. Hence, triangle OPN and triangle ONQ are congruent, right? Which means angle PON is equal to angle NOQ, corresponding part of congruent triangles. But we know that the sum of this and this is equal to 60 degree. Hence, both of them have to be equal to 30 degree each. So this is 30 degree and this is 30 degree. And with this, our problem of computing ON and NQ becomes easier, right? Now, if you see vis-a-vis this angle, you know this side, which is the hypotenuse. So in triangle ONQ, this is 14 centimeter, this is 30 degree. Now we know that the relationship between this side, which is the side opposite to angle O, and this side is what? It's sine. So sine 30 degree is equal to NQ upon OQ is equal to, what's the value of NQ? We don't know. Okay, OQ is 14 is equal to sine 30 degree, which is 1 upon 2, which gives us NQ is equal to 14 divided by 2 is equal to 7, right? Also PN is equal to NQ. Why? Because these are corresponding part of congruent triangles, is equal to 7, right? Therefore this is 7, we have computed here, this is 7. So PQ is equal to PN plus NQ is equal to 7 plus 7 is equal to 14 centimeter, right? Now similarly, this you've got. Now what is ON? Now the relationship between ON and OQ is what? This is cos. So cos 30 degree is equal to ON upon OQ. So ON is equal to OQ into cos 30 degree. OQ we know is 14. What's the value of cos 30 degree? That's root 3 by 2. So this knocks off 7. So 7 root 3. Right? Now what's the area of the triangle? Where is the area of the triangle? So area of triangle is equal to half into base. Base is PQ, which we've computed as 14, into height, which is ON, which is 7 root 3. 49 root 3. Okay, so the area of the portion PQ was, now you must have lost what the hell is PQ. So PQ was this portion. We said this area is equal to area of the sector less area of the triangle. So area of the sector was this, less area of the triangle. Okay, so 308 minus 3 into 49 will give you 147 root 3. Okay, so this is basically the area of the portion PQ. You can solve it further if you like it. Okay, but this is the area of the shaded portion.